In the vast darkness of space, astronomers have made a discovery that seems almost too beautiful to be real. These mysterious objects first caught astronomers' attention when routine sky surveys captured something unprecedented: asteroids that seemed to sparkle with all the colors of the rainbow. The first sighting occurred during a standard survey of the asteroid belt, when observers noticed an object that didn't behave like typical space rocks when reflecting sunlight. While normal asteroids appear as gray or brownish objects, these new discoveries exhibited spectacular prismatic effects, scattering light in ways never before seen in space. The difference was immediately apparent. Instead of reflecting light normally, these asteroids were breaking it apart into its component colors, similar to how a prism works. At first, many scientists thought their equipment was malfunctioning. The readings were so unusual that several observatories had to confirm the findings independently. Observatories around the world turned their attention to these objects, confirming that what they were seeing was real. We had discovered something entirely new in our cosmic neighborhood. The asteroids were nicknamed rainbow rocks by the astronomical community, though their official classification would prove far more complex. Detailed observations revealed surfaces unlike anything seen before. Complex crystalline structures that created natural prismatic effects, similar to opals found on Earth, but on a massive scale. With this discovery, astronomers found themselves at the beginning of a journey that would challenge our understanding of solar system formation and the very nature of the space between the stars. To understand what makes these asteroids so unique, we need to look at their remarkable crystal structure at the atomic level. On Earth, we're familiar with iridescence in opals, where tiny spheres of silica create stunning displays of color. But what we've found in space takes this phenomenon to an entirely new scale. These space crystals are arranged in perfect lattice structures, creating what scientists call photonic crystals, natural arrangements that can trap and manipulate light in extraordinary ways. The key to their formation lies in a unique combination of metallic elements, including rare earth metals like neodymium and yttrium, which naturally arrange themselves into these precise patterns. The absence of gravity plays a crucial role in allowing these crystals to grow to such unprecedented sizes and maintain their perfect structure. While similar crystals on Earth are limited by gravity and other forces, these space-borne structures can extend for meters, creating massive natural prisms. The precision of these structures is remarkable. Each layer is spaced exactly right to interact with light waves, creating the stunning rainbow effect we observe. As sunlight hits these asteroids, it penetrates multiple crystal layers, each one splitting and reflecting different wavelengths of light in perfect synchronization. The conditions required for these crystals to form are incredibly specific, which explains why we've never seen anything like them before. The precise mix of elements, the perfect temperature range, and the complete absence of interfering forces all must align, making these asteroids one of the rarest phenomena we've discovered in our solar system. These crystals aren't static. They actually respond to changes in temperature and radiation, causing subtle shifts in their color display as they orbit through space. As these asteroids travel through varying conditions in space, their crystal structures slightly expand and contract, creating an ever-changing light show that continues to captivate astronomers. The story of these prismatic asteroids begins with unimaginable destruction, the violent collision of entire worlds. Long ago, in the chaotic early days of our solar system, planetary bodies crashed into each other with devastating force, spraying molten material across vast distances of space. These impacts generated temperatures hot enough to vaporize metal and pressures so intense they could fundamentally alter the atomic structure of materials. In the aftermath of these collisions, droplets of molten material were flung into the cold vacuum of space. As they cooled, something extraordinary happened. The unique conditions created by these ancient catastrophes provided the exact environment needed for these remarkable crystals to form. The mixture of vaporized metals, rapid cooling, and complete absence of gravity allowed elements to combine and crystallize in ways impossible under normal conditions. But there's something else about these asteroids that has astronomers puzzled. Their orbits tell a story that might originate far beyond our solar system. The orbital patterns of these objects don't match anything else in our asteroid belt. They move in ways that suggest they might be visitors from another star system. If you're fascinated by these cosmic mysteries, hit subscribe to join us on more journeys through space. We've got a lot more to explore about these remarkable objects. These crystalline wanderers might be evidence of similar planetary collisions around other stars, carrying their beautiful but violent history across the galaxy. The formation of these asteroids required a precise sequence of events, like a cosmic recipe that could only be cooked up in the most extreme kitchen imaginable. First, the violent impact providing the heat and raw materials. Then, the perfect cooling rate in the vacuum of space. Finally, centuries of undisturbed crystal growth. These prismatic marvels of space hold a dark secret beneath their dazzling surfaces. While their beauty captivates us, these crystalline asteroids pose a unique and potentially catastrophic threat to Earth and other planets in our solar system. Their orbits follow patterns unlike anything we've seen before, making their movements particularly difficult to predict. These objects cut across normal orbital planes at extreme angles, some moving in retrograde orbits opposite to most solar system objects. This makes calculating potential collision courses extraordinarily challenging. The very properties that make these asteroids beautiful also make them exceptionally dangerous during atmospheric entry. Unlike normal asteroids that typically remain intact during entry, these crystalline structures would likely shatter along their perfectly formed layers, creating multiple high-velocity fragments. This fragmentation effect would turn a single asteroid impact into a cluster strike, potentially affecting multiple locations simultaneously. Their unique metallic composition presents another layer of danger during impact scenarios. The rare earth metals and complex crystal structures would vaporize upon impact, potentially releasing clouds of toxic material into the atmosphere. Traditional asteroid tracking systems struggle with these objects due to their unusual light-scattering properties. Their prismatic surfaces can create false readings in our detection systems, making size and distance calculations unreliable. What appears as a small, distant object might actually be much closer and larger. Current models suggest an impact from one of these asteroids would be fundamentally different from traditional asteroid strikes. The combination of fragmentation, toxic vapor release, and widespread debris patterns would create impact zones unlike anything we've studied before. While these prismatic asteroids pose significant dangers, they also represent an unprecedented opportunity for humanity's future in space. Within their beautiful crystal structures lies the largest concentration of rare earth elements ever discovered, materials crucial for modern technology and future space exploration. A single medium-sized prismatic asteroid contains more neodymium, dysprosium, and yttrium than all known Earth deposits combined, potentially worth trillions in today's market. But harvesting these resources presents unprecedented challenges, requiring entirely new approaches to space mining. Traditional mining methods would shatter these delicate crystal structures, destroying both their value and their unique properties. New technologies are being developed to extract resources while preserving their prismatic nature. Engineers are developing precision laser systems that can cut along natural crystal planes, allowing for careful extraction without damaging the surrounding structure. The unusual orbits of these asteroids present another major challenge for potential mining operations. Their erratic paths require new propulsion technologies capable of matching these complex trajectories while carrying heavy mining equipment. The potential impact on Earth's economy cannot be overstated. Successfully mining just one of these asteroids could revolutionize industries from renewable energy to quantum computing, potentially solving Earth's rare earth element shortage for centuries to come. Various space agencies and private companies are already racing to develop the technology needed to reach these cosmic treasures. Labs around the world are currently testing methods to handle these unique materials, marking the beginning of a new era in space resource utilization. These prismatic asteroids represent both the greatest challenge and opportunity humanity has faced in space exploration. If you found this fascinating, don't forget to like and subscribe for more incredible space discoveries. Thanks for joining us on this journey through the cosmos.